Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at outlier detection. That's another important aspect of data preparation and something that should be part of your initial data analysis. Effectively, outlier detection means that we're looking for unusual data values, things that are a little different from the norm. Now, there are different ways we can approach that. So let's go and have a look at some source data. For example, we've got our customer table, and we've got, for example, the new spend column, the most recent spend. So maybe as part of our initial data analysis, we were to take each customer and show the new spend values. So outlier analysis is a mechanism of trying to find values that we've got here for new spend that are a little different, that are maybe a little unusual, things we should be aware of. I should say that the fact that a value is an outlier is not necessarily bad. It may be that there's been an error in the input data. It may be that the particularly high or low values are natural. It may well be that they represent something that's fraud. So they're things you want to be aware of. The important thing is, as you do that analysis, is to investigate outliers and to make sure you understand where they come from and then deal with that. It's very important because certain algorithms are very strongly impacted by outliers. For example, just doing a simple mean, an average, is quite strongly impacted by outliers, the values that are right across the range, because you use all of the values in the calculation. Whereas if you're looking at the median, where you're taking the middle value, that's different because it's less impacted by what the outliers are. So, how can you do outlier analysis? Well, one way is just to visually do that. Draw a chart like this and just visually look to see maybe where the biggest and the smallest values may be. However, the PAL, of course, offers some automated ways of identifying this and using some very straightforward stats. Now, one way of doing that is to use what's called the variance test. The variance test calculates the outliers based on looking at the arithmetic mean and then the standard deviations from that mean. Let's see how it works. So let's go to some code. Of course, here's some code I made earlier. What we can see, we need to call a mechanism which is called the variance test. And as always, see the PAL reference manual to get more details on this. You input an ID to represent the data point and your numeric variable, in this case the new spend, and then you get two output tables. You get a table that gives you the mean and standard deviation value for that data set, and you also then get a table which identifies which observations, which rows are outliers based on your criteria. And then of course we'll define what our criteria is using the parameter table. So let's run that code to create our PAL_VT procedure. So that's now run. We can now go and set up our input data. In this case, we'll just take the new spend and the ID column from the input data set. We'll just create a view for doing that from customers. We'll create the parameters, the results and outliers tables, and we'll set the parameters in the parameter table. The thread number you're probably already familiar with. It relates to how the PAL will use the parallel processing capabilities, multi-threading inside the HANA server for performance. And the sigma num represents basically how many standard deviations from the mean we want to set that detection of outliers. So if it's set to 1, it basically means it's 1 standard deviation from the mean. Both sides, up and below and above the mean, will detect where we want to see an outlier. So let's run that. Now it's done, and we can run our first quick analysis. So if we now go and refresh our list of tables, we'll see we've got a VT results table and a VT outliers. So let's preview the results. So the first information we get in the table is to say what is the mean and what is the standard deviation of all the values of new spend. Now we saw before we had new spend, the values were basically between 0 and about 4.5. So it's already calculated that the mean arithmetic mean value is just over 3, and the standard deviation is nearly 0.5, it's about 0.44, 0.45. So what that allows us to know is that when we're calculating the outliers, it will say, okay, the mean is 3, the mean plus 1 standard deviation is about 3.49 or thereabouts, the mean minus 1 standard deviation is just over 2.5. Any value less than 2.5 and greater than about 3.45, I will flag as an outlier. So let's see what happened. Let's go to the VT outliers table and preview that. And yep, we can see we've got a set of outliers identified. In fact, there are a few of them. Now, it's not so useful looking at that raw output where we've got the ID and just a flag to say whether it's an outlier or not. So, however, what we can also do is if we just run a little SQL query, we can actually join this results data, so the outliers table, just for the outliers identified. So we'll filter where outlier is 1. And we'll join that on to the original data so we can actually see the new spend values. So let's run that. If we do that, now we can see just the outliers. So actually there are 48 outliers of the 150 total records. And we can see these are the new spend values for those. So it's the ones that are basically falling outside that range. They're 1 standard deviation plus or minus from the arithmetic mean. So we can see those are there, the higher and the lower values. Now that's quite a lot of outliers. Probably we need to refine this algorithm to find, outliers. You typically don't have a lot, otherwise then by definition they're not really outliers, they're really part of the norm. So what we could do is maybe increase the value of sigma num. So what that basically says is, in this case, if we set it to 2, multiply the standard deviation by 2, add that and subtract that from the mean, and the values that fall out that range will now be flagged as outliers. So let's run that example, and off we go and run. And now we can see in the results we only have 5 returned. And again, we're seeing this is the new spend values are higher or lower than we were previously seeing, because we're effectively taking that mean and standard deviation. We multiply the standard deviation by 2, which comes to about 0.9. We add that onto the mean, so that would be about 3.9. And if we look, the values here, they're all above 3.9. And we do the same, taking 2 standard deviations away from the mean to get the smaller outliers. And a third example we could do is maybe to increase that even more. Maybe we need 3 standard deviations, so a sigma of 3. And if we run that example, this time we will see we only get 1 outlier identified. It's in fact ID 44 with a new spend of 4.4. And if we go back to that original view, 44, you can see it's this number here. So it actually visually was fairly easy to see as an outlier. So in this simple example, I've shown you how you can use this PAL functionality to statistically identify outliers using the variance test. Now in the next video, we'll see a more complex way of doing this, a bit more sophisticated, and that's using 2 keys test.